Good afternoon, class. My name is Kevin White, and this is my demonstration for Artificial Intelligence CSE 525. I'm going to give a demonstration of how to perform sentiment analysis under the domain of natural language processing, which it falls under the umbrella of artificial intelligence. And what we're going to do is we're going to take raw Twitter text data and build a model that will predict whether tweets about 6 different US airlines are either positive, neutral, or negative. And that's what we call polarity in the sentiment analysis world. Okay, so what is sentiment analysis exactly? It's the analysis of opinions or feelings about something using text data. And it can be about services, such as services on an airline. It can be about movie reviews. It can be about feedback of certain Amazon products or reviews that you see in the IMDb movie website. Well, it's not easy to have analysts in a company go through one by one every tweet every tweet that is put out about let's say a presidential candidate or people's opinions about certain brands of soda or certain television shows. It's better to take a snapshot of about 20% of the data that comes in and then build a model that will then predict what a tweet is saying or the mood or the sentiment of the tweet based on the types of words that are being used. At some point, you can build a model that recognizes certain words usually correlate with certain polarities or sentiments of tweets. So why do companies need that information? It helps them modify their services, or it tells them certain products should probably be discontinued or possibly expanded upon. So it can be a real money saver for a company. And it also allows a company to determine what is being said about their product without having to have a staff of analysts to go over every single tweet that is put out about a product. So to do this, we're going to jump into the Jupyter Notebook, which you can get through Anaconda, and we're going to use the Python language. Well, to use the Python language, to use it effectively, you first need to start importing certain libraries. And you'll see I've got the NumPy, the Pandas library, the RE library, which stands for regular expression, and the NLTK toolkit. That stands for Natural Language Toolkit. And finally, we'll use matplotlib to give statistical graphics that will allow us to do an exploratory data analysis on our tweets. So I'm going to run this library and bring in the data. Now the raw data is sitting on this website. It's on a GitHub website. And if you were to click that address and put it into your browser, it would bring you to the raw text data. But I'm just going to show it to you here. This is what it looks like in a CSV file. You've got the tweet ID. You've got the actual sentiment of that tweet. Then you've got the confidence level determining, how close was that tweet to actually what it was meant to portray. Was it actually supposed to be negative? Was it actually supposed to be positive or neutral? Then we'll just scroll right over here. You've got the carrier. You've got Virgin Atlantic in the first of them, but we've got 6 other carriers. Then you've got the name name of the person who tweeted it, whether it was a retweet, how many times it was retweeted. And then if you expand this field, we actually have the actual text. So here's an example of something that somebody was very positive about. Okay, at Virgin Atlantic. Plus you've added commercial to the experience, or commercials to the experience. Tacky. Okay, so that word tacky has probably showed up several times in other negative tweets. And probably on the airline, they were constantly being bombarded with commercials on their entertainment service. Let's look at a real positive tweet. I'm going to go right here. I'm just randomly doing this. Okay, at Virgin America, view of downtown Los Angeles, the Hollywood sign, and beyond that, rain in the mountains. That sounds like something that was probably pretty positive. Now let's look at something that's neutral. So I'm going to scroll down here. Let's see. At Virgin America, at Carrie Underwood, at Lady Gaga. Sorry, Mary Martin, had it first. Those words, even an analyst probably would not know if that's negative or positive. And that's the difficult thing about sentiment analysis. Certain words might cancel each other out. Like in slang, somebody might say, this is crazy awesome. Well, crazy may be a pejorative, it may not. Awesome, well, are you meaning big awesome or awesome that's great? Also, if somebody is being sarcastic, that's pretty hard to detect. Like if somebody literally said, oh, what a great airline, but they were just being sarcastic, sentiment analysis probably would not pick up those words as such. Okay, so we see an example of what these tweets look like. And again, we have several thousand of them in this database, and we just don't have time to go through every single one of them. We need to build a model to score the polarity of this automatically using natural language processing. So I will bring in the data into Jupyter Notebook, and you always want to be able to just take a look at your first few rows of data. And let's see, I did head, that'll give me the first 5 lines. And I want to start setting up my graphics because I want to do an exploratory analysis. So let's do our first distribution pie chart. This pie chart is showing what proportion of the 6 airlines had tweets in my database. And you can see United had the most, and that's probably true because that is a larger carrier. And Virgin Atlantic was only, or Virgin America was only 3% of the tweets, and that's typical because they are a smaller carrier. Let's look at the distribution of the sentiment as a whole. So if you see here, 63% of the tweets about these 6 carriers are negative. And that's just kind of the nature of the business in the airline industry. You're not going to get too many pats on the back. You're probably going to hear more complaints than compliments. That's just the way it is. We pretty much take for granted the technology of airlines. Now let's look at the distribution of the sentiment for each of the carriers. You'll see that American, United, and US Airways, they have a disproportionately larger amount of negative tweets than positive tweets. Virgin America, they seem to be doing pretty well. They have a balance of positives to negatives. So that's probably a good sign for Virgin America. Now let's look at something else. Let's go further down and let's see the proportion of tweets overall. So from the output, you can see this is the confidence level. The confidence level is going to tell us how true to the sentiment that tweet was. It looks like confidence levels for neutral tweets are probably not that high. Negative tweets probably much higher in confidence levels. And that's to be expected. they're probably using very extreme words to say something negative, like hate, delayed, broken, something like that. It's kind of hard to mix extreme negative words into something positive. So that's just going to test our confidence level. Okay, so we've done enough exploratory analysis. Now we have to do what's called vectorizing our data. We need to take all of that text and turn them into numbers. That way we can do a statistical analysis on the tweets. So we're going to do a few things here. And it's pretty complicated, but you'll see it's not so bad when you have the scripts in Jupyter Notebook. So in the script that we have here, center mass of the screen, we're going to start by removing all of the special characters. We need to get rid of the @ symbols. We need to get rid of the RTs. We need to get rid of pound signs. Next, we're going to remove single characters. And those are usually what's left as a result of removing special characters. Now, if we replace all the single characters with space, multiple spaces are going to be created, and therefore we need to get rid of multiple spaces. So we need to get rid of all of the areas where there's just too many spaces. It should be, in the end, everything should be lowercase, simple words, only separated by one space. This is going to allow us to build a corpus, a word corpus. And by doing that, we're going to be able to represent this text in numeric form. So we're going to use statistical algorithms to train our machine learning model. If you look down here, we're going to use, well, let me go back a minute. If you look at line 41, we're also going to remove stop words. There are certain words that we just don't need to analyze. Articles like the, and, or conjunctions like and, or. They're just certain words that they don't really mean anything. So we're going to remove all of the stop words. Now, what I want to do next is I want to start splitting my data into test and training data. And that's going to be dividing 20% of the data is going to be used for testing, and 80% of the data is going to be used to actually train this model. So let me go back through and run everything one more time. I just want to make sure I didn't lose my place. Okay, now we've processed our text data, and I'm now splitting my data up into testing and training, 20% for testing, 80% for training. Okay, now that I've split my data, once the data is split into training and test data sets, the machine learning algorithms are going to be used to learn from the training data. And you can use any machine learning algorithm, but we're going to use what's called random forest classifier. And this is good for things that are like non-normalized data. So I'm going to run that line. And then we're going to start making predictions on that data set of tweets. Once the model's been trained, the last step is going to be to make those predictions. And to do so, I'm going to use the predict method. And that is an object of a random forest classifier. So I run this. And then finally, we have to evaluate the performance of that machine learning model. And we're going to create a confusion matrix, a classification report, and an accuracy score. So let me take you down here and let's see how our model actually performed. And looks like we had it. I might have to run this one more time. But when it comes out, you're going to see it's going to tell what the true positives were, the false positives, the true negatives, and the false negatives. So let me see. I may have to restart this, and that's fine. I'm going to restart it right now. Sometimes you have to do that in Jupyter Notebook. Jupyter Notebook can be pretty finicky. So let me run all the cells. And if you're ever wondering, like, how long it's taking, you can look, you'll see an hourglass up in the upper left-hand corner of the screen, and it'll show you exactly what's going on. Okay, looks like I'm hung up. I will start this one more time. And I'm just going to do this one by one. Actually, I have it already out here. Okay, so it looks like out of our entire data set, these were our true positives. We had 1,723, and then we had 108 false positives, and that's not great. And then we had 326 false negatives, 248 true negatives. So we'll probably have to adjust these parameters a little bit. And what it's going to show is it's going to show us our precision, our recall, and our F1 score. So, what does that mean? Well, recall means out of all of the positive classes, how much we predicted correctly, and it should be as high as possible. You really want that recall score to be high. So for negatives, it's pretty easy to train a model to detect negative tweets. For neutral, not so easy, because it's not easy to determine whether what somebody's talking about is just neutral or not. Now, precision, that score is going to be out of all of the positive classes we've predicted correctly, how many are actually positive? And then we've got that score in the far left-hand column. And with the F score, the F1 score, it's difficult to compare two models with low precision and high recall or vice versa. So we just make them comparable. An F score is going to help you measure the recall and precision at the same time. And it's a better way of classifying or comparing how your model is doing. So what we've done is, from going forward, we've now created a model that can detect sentiment in raw tweets coming off of social media. Now, if you are working for an airline, you can start tracking whether your airline is doing well or not. And you can even go further with this. You can start doing things like a BERT model, which will start clustering what people are saying. It'll start pulling out words talking about food, cabin service, dry steak, bad drinks, and then you'll say, okay, well, the tweets are probably about the catering service. Or all of the words will cluster and start talking about late, cancellation, too early in the morning. Okay, well, that's a scheduling issue. So what I've demonstrated here is how you can build a sentiment analysis based on analyzing raw text data. And I appreciate everybody for listening, and I hope everybody has a good day. Thank you.